Hello everyone. So in today's video we are going to solve this question. This question is from sequence and limit, you can say, and the question was sent to me by one of my students. So this is question number 33 in problem you must try, and of course you should try this question before watching the solution. The question says that there is a sequence of numbers a1, a2, a3 up to an which satisfies this equation. The first term of this equation left hand side is n plus 1 by n plus 1, and second term is n minus 1 by n. The difference of this is equal to twice of n plus 1, n plus 2 by n, and of course n runs from natural number, and actually it is defined for n greater than equal to 1. Alright, so if n greater than equal to 1, we have to start and we have to find out the limit of n to the power 4 times the product of this ai's running from 1 to n. So first of all we have to identify what is the formula for the an, then we will substitute it there, then find the product, and then we have to evaluate the limit. So for the main challenge is how do we find the an. So for that you can see that this is the information I have, that n plus 1 by an plus 1 minus n minus 1 by an, and this is actually given. You can notice that the n is here, so I just multiply throughout this n. So this will give you n plus 1 times n. Let me write a little bit clearly. This is minus, and here I am writing again n, so it will become n times n minus 1, and that is twice of n plus 2 is 2n plus 4, by the way. Okay, you notice that this is actually giving you the idea this is some other kind of sequence and at n plus 1th term, because if you're substituting n plus 1 there, you are getting this thing and this is yours. So identify that suppose I'm writing the new sequence is a un plus 1 and minus un is equal to 2n plus 4. So what do I assume there? I assume there that the un is equal to n times n minus 1 by an. So you notice that if I substitute n is equal to 1 there, so u1 will become 0. Now in order to find the an, let's sum them up. So I'm just applying the summation here, and let's say k I'm writing here, k runs from 1 to n, and that is uk plus 1 minus uk, and this side summation k goes from 1 to n 2k plus 4. This guy will become a telescopic, and of course we are left with the last term as uk plus 1 and the first term as u1, and here I can apply the summation, all the special summation. So this is twice of, and k into, this is k runs from 1 to n, so it will become n into n plus 1 by 2, and this 4 will run from 1 to n, so it will become 4n. Now this u1 is already, we have found 0, so we got uk plus 1 is equal to n squared plus 5n. Once we got uk plus 1, I can directly substitute the assumed value of the uk. So let's find the uk actually, or not uk, this is un actually, because substitute n there. So un plus 1. Okay, so we got here un plus 1, so we substitute there n minus 1, so we get un is equal to n minus 1, or let me write in this way so that will be easy to convey the idea. So un plus 1 so far we got as n times n plus 5. Now I'm substituting n minus 1 to get the un. So un is nothing but n minus 1 times n plus 4. And you can see that the un is also here n into n minus 1 by an. So I'm substituting that thing as n into n minus 1 by an, and that is n minus 1 n plus 4. So from here you get n minus 1 cancel, and we got an is equal to n by n plus 4. Now we have to find out the product And so let's just find the product first. I am interested to find the product only first, and then whatever result will come, I will substitute at the place of this, and we then find the limit of it. So for that, let's find the product. So product says that I goes from 1 to n, and here I have ai. So let's find it here. So that is going to be the first term, and of course this is a little bit of formula first. So I goes from 1 to n, and that will give you I by I plus 4. So let's find the product. So I'm writing the product starting from here. So the first term will give you 1 plus 1 by 5. So because the difference is 5 here, we should think a little bit wisely, because it's not the summation, it's a product. So until we reach the fifth term, we can't get the cancellation thing happening. So let's just reach there. So 1 by 5, then you get 2 by 6, then 3 by 7, then 4 by 8, then 5 by 9, and one more, right, 6 by 10, and dot dot dot. You can see that the cancellation is happening now. This is a 5 is cancelled here from this, 6 is cancelled here from this. Similarly 7 will cancel there. So from the first 4 terms we are saved with 1 2 3 4. Now the similar thing we have to understand from the end, and for that we are not writing that the last 4 terms or 5 terms from the beginning, we are writing from the end. So the last term will be, so that you can understand it, so last term will be what? Okay, I don't know why I have taken so many dots. So the last term will be n by n plus 4. So before that, what I got is n minus 1 by n minus 3, sorry, n plus 3. Then we get n minus 2 by n plus 2. Let me take this thing a little left, right, sorry. Okay, and then before that we get n minus 1 by n plus 1, and then we got n minus, not n minus 1, n minus 3 by the way, and there's a n minus 4 by n. So you can see that this is the cancellation thing is actually happening like this, n then n. So you can notice that the n minus 4 will also get cancelled here. Before that n minus 3 will also cancel, n minus 2 and n minus 4, means this last 4 terms will be left out from the end, and this first 4 terms will be left out from the beginning. So this 1 2 3 4 will come in the numerator, and the last 4 terms n plus 1, n plus 2, n plus 3, and n plus 4 in the denominator. Now this is the product we got, and we have to evaluate the limit. L is equal to limit n tends to infinity, n to the power 4, and then remind you product I goes from 1 to n, ai. So this is already we have found as this term. So I'm just substituting this thing, and many students might have understood this part. So limit n approaches infinity, n to the power 4, and that is going to be 24 on the top, and denominator I have n plus 1, n plus 2, n plus 3, n plus 4. You can notice that there's an infinity by infinity format, and this is going to be power 4. This is also degree 4. So, and the leading coefficient is 1 and 1. So this will directly give you the 1 for the limit n tends to infinity, and therefore our answer is 24. The limit value is 24, and so the sum of digits they're asking, the answer is 6. So why I have given this answer like L is equal to 24? Because it is necessary to know that this answer is 24, because then only you'll get the correct understanding. Otherwise, maybe you are getting, suppose 1 in 5, the limit is 15, of course the sum of digits is also again 6. That is not needed. All right, so this is all for today's video. See you in the next video with some other problems you must try. Till then, stay math active.